Hello, my name is Musay Valisa, and today I will cover the Raft consensus algorithm for my distributed systems class. My CRN is 20911. So let's start with with what's distributed consensus and why we need it. So what's the problem? We have multiple nodes, let's say servers, database servers, whatever. We have multiple nodes and they store some data. Imagine we have a store, online store, and we have a stock of some product. And one server says the stock is 2, one says the stock is 1, and one says that we are out of stock. What will happen when a user comes to our website? They will see that we have some stock. Let's say they see that stock is 2. They place an order. They don't get any error message or whatever. They successfully place an order, and then we see that we are out of stock. So this is a problem, right? And how it should be in the real life. All our servers should have a consensus on the data. They have their data synchronized. They should store the same data. So this is why we need the consensus. Okay. And how this Raft algorithm works. First term is cluster. What's a cluster? So we have here group of nodes. This is a cluster, and each cluster has one leader node. This leader node is responsible for these log entries. It is responsible for their followers to synchronize these log entries. We'll talk more about log entries and how leader is selected in the next slides. So let's talk now about how leader is selected. First, how leader works. It sends heartbeats to its followers. What's the purpose of these heartbeats? These beats show that this leader node is still alive, is still working, it can process data and whatever. So the candidate nodes, when they don't get these heartbeats, they throw an error, they throw a timeout error, and they become a candidate. Let's say node 2, it had 100 ms timeout period. It didn't get any heartbeats from the leader for 100 ms, and it becomes a candidate. So now all other nodes start voting. They vote this candidate, and node 2 becomes a leader. But what happens? Imagine we have 100 ms here, 100 ms here, and 100 ms here. All of these nodes will get the timeout at the same time. Which one will become a candidate? To prevent this, we don't just assign a hard-coded number as ms. We assign a random number. For example, here we can assign 163 ms. Here we can let's randomly keep it 100, whatever, and here it is 200 ms. So now we prevent this multiple candidate thing. But let's say we still have two candidates, node 4 and node 2. What will happen then? We will look at their log lengths, and the longer log, it means it is the newer version of the log. There are new entries to the log. That means we'll vote again candidate 2 because it has a longer log length, and again candidate 2 will become a leader. We will have a democratic voting, and more votes it gets, it becomes a leader. Okay, so we talk a lot about log entries, but what are the how these logs work? We have here index of the log and the term of the log. What is a term? Here, imagine when we had this node as a leader, it was term 3. So this node died, we selected a new node, so it becomes a new term. For example, it becomes term 4. Okay, so new term becomes when a new leader is selected. So this is term number, this is index. Index is just monotonously becomes bigger and bigger, 4, 5, 6 as new log entries become. And imagine we have a leader, and this leader stores some logs, and its followers also synchronize with the leader. So it stored a new log entry with index 3. It sends it to its followers, and these followers, when they get it, they append it. They don't commit it yet, they just append it to their logs. So when they append, they return that they appended this log, and when majority of the followers appended this log, leader can commit it. When leader commits it, it again sends information about it, and their followers also commit it. But what happens? We say that if majority appended, so that means there are some followers that might not append it. They might be out of operation. So when some follower is out of operation, we see here leader has appended a lot of log entries, but follower 3 was out of operation and it doesn't have them. Let's say it became it works again, and these followers can easily append this log term, log entry. They appended it, they returned, appended, return. But this entry, if it returns that it appended, it won't have the up-to-date data because it misses some log entries. So leader with alongside this log item, it will send the index of previous log item. In our case, it is index 4. So it will send 4, and follower 3 will check if it has the 4th log entry. It sees that it doesn't have, it again sends information about it to the leader, and leader again goes up, and now it sends index 3 and the previous index 2. Our follower 3 will check index 2 is in its database, in its log items, and it will append index 3 first, log 3 first, and the other logs with the same algorithm. So okay, we covered, let's just summarize everything. We need consensus to keep the data up to date in each node. We have a cluster. This is group of nodes with a single leader, and we have log entries. Log entries also used to keep nodes up to date. We covered leader selection, voting system, terms, and how leader keeps up to date its followers, and what happens when this some follower, some node is out of operation. And yes, thank you for listening. Goodbye.